Okay, so we were going to talk about end behavior. As I'll go back and I'll explain this end behavior as we're looking at these little graphs right here. So I've copied and pasted these onto this little thing right here. And just when they're talking about end behavior, they're talking about what's happening on the ends. Now, you know from the previous unit that we did that a quadratic looks something like this. It's in the shape of a parabola. It has a vertex at the origin, passes through 0, 0. Okay, this is what they're talking about when they say end behavior. What this is saying is that the right side of the graph. Okay, and when we're talking about right and left, remember we're talking about x's. These are x's, and these x's over here are going towards the right direction. So that's going towards positive infinity. So we're talking about x moving to the right. As we move to the right forever and ever and ever, what is happening to my graph? As we're looking at the negative x values, or as my x is going to the left, what is happening to the end of this graph? Okay, so we can describe this by saying as the on the left side of the graph goes up. I think most of you would be okay with that description. On the left side of this graph, the graph is going up. And we would say the same thing about the right. On the right, the graph, graph goes up. The problem is that, I don't know who, but the people of mathematics are lazy, and they don't like having to use all of these words. So they don't use the words on the left and on the right. What they do to describe that part right there, what the symbol that they would use right here would say as x approaches negative infinity. That's how they would, that was the symbol that they would use to stand for on the left. The graph goes up, they would say y, or they would say f of x goes to positive infinity. Okay, that's the symbol that they would use here. On the right, okay, right and left is always talking about x value. So here they would say x approaches, right is positive. Then the graph, they would say either y or f of x goes up, and up is positive infinity. Okay, so there's the notation that they would use. What's going to happen over here on this one? Well, we know that negative, leading coefficient negative, makes the graph open down. So we could say, and we can also combine them. We separated them here. As x went left, as x goes left, the graph goes down. As x goes right, the graph goes down. We could say at the same time, as x goes right and left, okay, right and left, positive and negative infinity, that's how we say as x goes right and left, then the y function is doing what? In both cases, it's going down. Now, they don't have to put them together. They could totally separate them, but you need to be able to be okay with both. You need to be able to be okay with them separating it, doing it individually, or doing it together. Okay, x cubed, type it in your calculator if you want to see what it looks like, but this is basically it. It's a pretty bad sketch, but that's what x cubed looks like. And what's happening here as x goes to the right, what's the function doing? It's going up. And as x goes to the left, it's going down. So as x moves to the right, my function, I'm going to use f of x this time, is going up. As x goes to the left, or as I'm looking on the left-hand side of my function, comma, my function or my y values are going down. Okay? And sometimes, depending on which textbook you're looking at, sometimes they even list the y values first. Okay? I'll practice that over here. So this one, type it in your calculator if you want to know how I know what it looks like. I just know what it looks like because I've done them 100 times. Negative x cubed. Okay, so what's happening over here? This time we're going to write our x values first. My my function's going up. Whoops, I put equals. I didn't mean to put equals. Just let me erase that. Okay, so my function's going up. Here's where my function is going up. Well, which side am I on? I'm on the left-hand side. And this is the symbol for left. As my function's going up, I'm on the left-hand side. What's happening when my function's going down? When is my function going down? When I'm on the right-hand side. How do I write the right-hand side? You say positive infinity. Okay, so lots of variations. You can separate them. You can write them together. You can use function notation. You can use y. You can write the y values first. Okay. These are the ones that usually get written together. The reason that they get written together is because they're doing the same thing. Now, this one looks very much like a parabola. The difference is that it's a lot wider in the middle. And actually, if we had some other terms, something like this, I don't know. Don't put those numbers in because it may not. But it would do all kinds of crazy stuff in the middle. The point is I don't care what it does in the middle. All I care about is its end behavior. Okay, and if it's a fourth degree polynomial and the leading coefficient is positive, the end behavior is going to be the same. Even degreed polynomials have the same end behavior. Odd degree polynomials have what we call opposite end behavior. One goes up, one goes down. Okay, so this one, as x approaches the right and the left, then my y value is going up. If it's a negative and I had a bunch of other squared terms up here, something like that, then who knows what it would do. Something like that. These are, by the way, are called the turning points. These are the turning points. I think I've got too many. 1, 2, 3, 4. I do have too many. Because remember a while ago I told you that the number of turning points had to be 1 less than the degree of the polynomial. So 1, 2, 3. That's all the turning points I can have. But still, the fact that the leading coefficient is negative, it's an even degreed polynomial, then my end behavior should be the same, and this is going to be negative. So you can do the same as x goes both to the right and the left. Then my function, my y values, are going to be going to negative infinity. They're going to be going down. Okay, and this one would be very similar to the cubic one. Again, it could be doing all kinds of things in the middle, but the end behavior is going to be different. As x approaches positive infinity, y is going to be, or as x is moving to the right, y is going to be going up. As x is moving down, y is going to be moving down. Okay, and same thing with this one over here. This one's going to be going this way. This one's going to be going that way. I know it's going up to the left because it's negative. And again, we'll practice doing the y value first. Uh-oh, I'm running out of time. As y goes up, where am I? I'm on the left. As y goes down, where am I? I'm on the right. Okay, so there's end behavior.